Hey, what's going on, guys? We're back with the next part of our Learning C# tutorial, and today we're going to go ahead and try and add in our x-axis tick marks. So something for our wind correction. Eventually, we're also going to do our distance tick marks, our up and down ones on the y-axis, but we'll go ahead and do that once we actually get the distance system working. So I know I put the comment in here, but we're actually going to go ahead and do it in our overlay GUI because it's easier to access the certain rectangles that we want from there that we've already set up. But before that, we're just going to do something I forgot to do in the last video. We're just going to do a check to make sure that our power is correct. So you'll notice that, remember, we decided on doing a 0 to 100 power scale. So we want to make sure that our power is in that range, or else, you know, the wind could be affected interestingly. It could be actually larger than it should be. Let's say if we put in negative power, or if our power is too strong, you would think that there would be a zero wind, but it would actually make the wind negative, and we don't want that. So what we're going to do is we'll do if current weapon dot power is greater than 100, current weapon dot power equals 100, and then we'll do else if current weapon dot power is less than 0, current weapon dot power equals 0. Okay, let's just make sure that our power is set up correctly. And if you wanted to, you could do some sort of debug statement saying, oh yeah, just so you know, you make sure that your power is in the correct range. You could, but I'm not going to go ahead and do that. And that reminds me, I don't know if we talked about this before, but you'll notice I did not use brackets. And cool thing about C# is that take into account you can get lazy, I guess. So if you don't put in brackets, what is considered to be the line of code that will be run if the if statement is true is just the line right after it. So the single line here, and you'll notice if I put in, let's say that was some other code, even though it's indented, this code would not be ran. It would be considered top level code just because there's no brackets. So in order for me to get this code and the next code, you would need to have brackets. But when there's something simple like this, where it's only doing this one line of code, it's easier not to use brackets. Okay. Now let's go ahead and remove this, and let's go ahead and actually start to get working on our tick marks. So I'm going to go ahead and do it right here before we do all this other background black stuff. In fact, we'll do r equals get mouse rect, just so we can reset itself, because that's where it should be. And then in here we'll do our tick marks, or we'll do x axis tick marks. Okay, I think the largest we'll have the wind will be, we'll stick with the 100 for now. If it ends up being more or less, we can go ahead and change it. So we'll do for int index equals -100, index is less than 100, index plus equals 25. So we've talked about for loops before, and a quick rundown is this is basically a while loop, except that it'll only run not while this is true, because this is a complex statement. It'll initialize a new variable for us of type int, and we're setting it to -100. Then it'll run the code, and then when it comes back here to do the check, it won't rerun this index. What it'll do is it'll use that same index, and then it'll check if it's less than 100. So it'll do this check statement, and if it's true, run the code again, and then do this effector. And then so the next time it comes up, oh, index plus 25, and now let's run the check again, and it'll keep running this until index is not less than 100. So essentially what this will do is it'll start index at -100, then keep running till -75, -50, etc., up until you get to 100, and that's when it's going to stop. And we're going to use this for setting tick marks, -100 all the way to 100 x units, x pixels along the overlay. So what we want to do is let's go ahead and make a new int. We'll do int value is equal to r dot xmin. We'll do plus index. So even though we're saying plus index, we need to cast this to an int. Or rather, a better way of doing this, we'll do, well, I guess it doesn't matter, but here's another way. We can cast this to a float and just make our index a float as well. So it's either casting these two to floats or casting our xmin to an index, because xmin an integer, because xmin is a float. However, these are indexes. An index cannot be added to, well, they can be, but in order to assign it to a float or to an int, you can't add a float unless you're adding it to a float variable. Okay? In fact, I can remove these actually if I wanted to. So now that we've got our x value, we'll do GUI dot label, and we'll do new rect, and we'll do value r dot this is our height, so it'll be our y min. Then our width will be the r dot width and the r dot height. Okay. Now, obviously, in here we instead of using a label, we would want to draw like some sort of a line or a tick mark. Just one way around it. We'll just go ahead and print that. Okay. Let's go ahead and test this out. Okay, so you guys will notice I paused it and moved it over to a bit. You'll notice we have our tick marks out here, and the reason for that is because we plugged in our the old x, or the old rectangle's x position, which was not in fact the middle, but the left coordinate of it. So this is the left coordinate, the y coordinate, and so what we need to do is revise our code a little bit. I'm going to stop running this. And not in here. So instead of plugging in our y min, we'll go ahead and do r dot. Oh, we do have a center. That's cool. That's useful. We'll do r dot center dot okay, yep, dot y. And here we actually want to change this from our x min to r dot center dot x, and then these two can stay the same. Now if we run it, we now have our tick marks there. Obviously, because the recs are a little bit above, or if I hit pause right here, that's where that negative 100 is, and because GUI draws down, that's why it's looking below the middle. We'd have to actually make it slightly above the y-axis for it to line up exactly. In fact, I'm going to go ahead and do that now. In fact, not only am I going to do that, I'm going to make this negative. I'm going to make this negative 200, going to 200, incrementing at. Yeah, incrementing at well, yeah, 50. Okay. And then we'll do just minus 5, so that'll bring it up 5 pixels. Okay. Now, what we're also going to want to do is we're going to want to print the number here as well. So let's go ahead and do a GUI dot label, and we'll do we're going to copy this real quick. And then we'll do index.toString. Okay, and now we want to move this down a bit, so we'll actually turn this into a +5. Okay, and we're going to go and put a -5 in our x because we want to move it to the left a little bit. So now if we go ahead, and this may or may not recompile. Oh, it does. Good. Okay. Sorry about that, my recording stopped. So you'll notice now we have our tick marks as well as our numbers there. And for some reason, my input manager or level manager is not compiling. I'm gonna restart Unity real quick. Okay, I got and tested it, and turns out we do have a small bug in our level manager with concerning our iCharacter system. It's a rather simple fix, but that's not what this tutorial is about. So we'll go ahead and fix it up in a later tutorial. You guys can obviously see we do now have our tick marks working, and if our power corrected wind is 50, our aiming is now fine. We can go ahead and change it to something more complex. Let's see. Let's change our wind to 200, and we can go ahead and make our power. So let's make it, I don't know, some random number, 26. Okay. So our percent corrected wind, or power corrected wind is 148, which would be like here. There we go. So next video we'll probably either fix our level manager a little bit, or continue with our character system, or continue with the power system. I'm not sure, whatever I feel like doing. So I'll see you guys next time.